Hello everyone, my name is Clarissa Molina, and during the fall of 2022, I got to work in Dr. Crossley's lab studying alligator physiology. Many people are familiar with the American alligator, an aquatic reptile native to wetlands across the southeastern United States. Like all vertebrates, the alligator possesses a short-term homeostatic mechanism known as the baroreflex to regulate arterial pressure changes. So the arterial pressure changes past a certain threshold, and the baroreflex's job is to kick in and drive heart rate in the opposite direction to re-stabilize those pressure levels. We measured the function of the baroreflex in response to two drugs that altered arterial pressure: phenylephrine, known as PE, and sodium nitroprusside, SNP. Phenylephrine is what's known as a vasoconstrictor. It constricts or narrows the blood vessels and the pressure increases. SNP has the opposite effect. As a vasodilator, the blood vessels expand or dilate and the pressure decreases. Every animal received a single dose of each drug, and we analyzed the beat-to-beat changes in blood pressure and heart rate. Now, throughout the trials, we saw the baroreflex at work. We observed the inverse relationship between heart rate and arterial pressure, but what we did not expect to see, and what has yet to be observed in alligators, was the disproportionate response to the baroreflex to the different pressure conditions. So let's break this down. During the SNP trial, as blood pressure decreased past the threshold, heart rate shot up pretty rapidly and significantly. However, during the PE trial, as blood pressure increased past its threshold, heart rate decreased a little bit, but then stabilized. This is very interesting, especially when we consider that heart rate during the PE trial was already at the lower end of its normal range when compared to the resting heart rate just before the PE trial, which was higher. This suggests that baroreflex sensitivity is dependent on the type of pressure change, because heart rate couldn't decrease as much in response to PE as it was already at its lower limits. This also suggests that alligators may be more equipped to defend against decreasing pressure than they are against increasing pressure. Our findings contribute greatly to the study of vertebrate physiology and really lay the groundwork for future investigations of baroreflex function. Because the study is still ongoing, we'll be able to really explore and unpack the complexities of this novel phenomenon we've just discovered. Thank you so much for listening.